There is a dream almost every human being has had at least once in their life. You are stuck somewhere inconvenient, maybe in traffic, maybe in a long airport security line, and suddenly you imagine how wonderful it would be if distance simply stopped existing. With one button press, you disappear from where you are and instantly appear somewhere else. It is a powerful fantasy because it promises freedom from the slow mechanics of travel. No waiting for flights, no crowded buses, no delays or jet lag. Just step into a machine and appear in another city, another country, or even another planet. Science fiction made this idea feel normal. Shows like Star Trek presented teleportation as clean, simple, and elegant. A glowing beam dissolves the body and then reassembles it somewhere else. To the viewer, it looks like transportation. One moment you are on a spaceship, and the next moment you are standing on an alien planet. The character seems perfectly fine, continuing their conversation as if nothing strange happened. But physics is not written by television writers. The universe follows extremely strict rules that do not care about our convenience. And when we examine those rules closely, teleportation stops looking like transportation. Instead, it begins to look like something much darker. According to the physics we currently understand, teleportation would not move you anywhere. It would destroy you and replace you with a copy. That sounds dramatic at first, almost like philosophical speculation. However, the idea actually comes directly from the principles of quantum mechanics. The same rules that explain atoms, particles, and the structure of matter create a serious problem for teleportation. To understand why, we have to start with a simple question. What exactly are you? Not philosophically or spiritually, but physically. From a physics perspective, you are a collection of atoms organized in an incredibly precise structure. There are roughly 7 octillion atoms inside the human body. Carbon, hydrogen, oxygen, nitrogen, calcium, and dozens of other elements form a living system. Those atoms are not arranged randomly. They are organized into molecules. Cells, tissues, organs, and finally the brain that produces your thoughts and memories. Every memory you have ever formed exists as a physical pattern inside the structure of your brain. Your favorite music, your childhood memories, your fears and hopes are all encoded in the arrangement of neurons and electrical signals. If that arrangement changes, your mind changes with it. In other words, your identity is deeply connected to the physical pattern of matter inside your body. Now imagine you want to teleport from Earth to Mars. There are 2 basic approaches that physics could allow. One is straightforward but extremely difficult, while the other sounds easier but hides a terrifying consequence. The first option is to physically move every atom of your body through space. That means placing you inside a spacecraft and accelerating toward Mars. It might take months, but the atoms that make up your body remain together the entire time. When you arrive on Mars, you step out of the spacecraft as the same person who left Earth. The continuity of your physical structure remains intact. Your atoms traveled through space as one connected system. This is essentially how all travel works today. Planes, ships, trains, and rockets simply move your body from one place to another. It may take time and energy, but your identity remains continuous. Teleportation proposes something completely different. Instead of moving the atoms themselves, the machine attempts to move the information that describes them. The idea is to scan the structure of your body, transmit that information, and rebuild you somewhere else. In this scenario, the machine first performs an incredibly detailed scan of your entire body. It measures the position of every atom, every molecule, and every neural connection inside your brain. The result is a perfect map describing exactly how your body is arranged. That map can then be transmitted as data, just like sending an email across the internet. The pattern of your body could theoretically be sent from Earth to Mars at the speed of light. Once the information arrives, another machine uses it as instructions to rebuild you. On Mars, the machine gathers raw atoms from the environment. Carbon, hydrogen, oxygen, and other elements are assembled according to the instructions contained in the data. Eventually, a human body identical to yours is constructed atom by atom. When the reconstruction is complete, the eyes open and the brain begins functioning. The person stands up and believes they have just traveled from Earth. From their perspective, the teleportation worked perfectly. They remember entering the machine on Earth. They remember the flash of light and the feeling of anticipation. Now they are standing on Mars with all of those memories intact. From the outside, this seems like success. The person looks identical, speaks the same way, and remembers the same experiences. friends and family would likely accept them as the same individual. However, the crucial question is not whether the copy behaves like you. The real question is whether the original you survived the process, and this is where physics introduces a serious problem. Quantum mechanics includes a principle known as the No-Cloning Theorem. This rule states that it is impossible to create a perfect copy of an unknown quantum state without destroying the original. In simpler terms, you cannot perfectly duplicate the exact state of a particle while leaving the original unchanged. Why does this matter? For teleportation. Because your body is not just a classical arrangement of atoms. At the microscopic level, it contains quantum states that define how particles behave. To reproduce your body perfectly, the teleportation machine must measure those states with extreme precision. It must know the exact configuration of every particle inside you. Without that information, the reconstruction would not be identical, but measuring a quantum state changes it. This is related to Heisenberg's uncertainty principle. The act of observation disturbs the system being measured. Therefore, the teleportation scanner cannot simply look at your atoms harmlessly to obtain the information required for reconstruction. It must interact with them in a way that destroys their original state. In effect, the measurement process tears apart the structure of your body. This means the teleportation machine does not gently scan you, it disassembles you completely in order to extract the data. Every atom must be separated and measured individually. The process would effectively vaporize the original body. The structure that once formed your living system would be broken into isolated particles. Your biological processes would stop instantly. Meanwhile, the information describing that structure is transmitted across space. On Mars, the reconstruction machine uses new atoms to rebuild. The pattern: a person appears who is physically identical to the one who entered the machine. But the original body on Earth no longer exists. The chain of biological continuity was interrupted during the scanning process. From the perspective of physics, the original individual ceased to exist. The person who appears on Mars is a newly created system that happens to share the same pattern. They possess the same memories and personality traits. However, their consciousness began at the moment of reconstruction. To the copy, this difference is invisible. They believe they are the same person because their memory includes the moment before teleportation. But the original stream of experience ended when the scanning process destroyed the body. Imagine recording a conversation on your phone. If the phone is destroyed but the recording is copied onto another device, the audio still exists. Yet the original device that captured it is gone. Teleportation treats a human being the same way. The pattern of information is preserved, but the physical system that originally contained it is destroyed. From a strict physical viewpoint, that means the original person died. This conclusion makes teleportation deeply unsettling. The technology would not transport you anywhere. Instead, it would create a duplicate somewhere else while eliminating the original. The duplicate might behave exactly like you. They might continue your life, talk to your friends, and pursue your goals. But the conscious experience you call your life would have ended during the scanning process. For the person stepping into the machine, there is no guarantee they will ever experience the destination. The machine might produce a perfect copy on Mars, yet the individual who pressed the button would never see it. This creates a disturbing thought experiment. Suppose someone offers to teleport you instantly to another planet. They explain the process honestly and tell you exactly what will happen. They say the machine will destroy your body while extracting the information needed to build a copy elsewhere. The copy will continue your life exactly as if nothing happened. Would you agree to step inside? Most people instinctively hesitate. Even if the copy behaves exactly like them, something feels wrong. The idea of voluntarily entering a machine that destroys your body triggers a deep psychological resistance. The reason is simple. Human beings care deeply about the continuity of their own consciousness. We want our personal stream of experience to continue uninterrupted. A copy living somewhere else does not satisfy that desire. The copy may believe they are you, but your experience would end before they ever take their first breath. From your perspective, teleportation becomes indistinguishable from death. This realization turns a beloved science fiction technology into a philosophical nightmare. What once looked like magical transportation now appears to be a sophisticated execution device. The universe refuses to let us cheat the laws of identity so easily. And the strangest part is that physics itself does not consider this paradox unusual. At the level of atoms and information, identity is not a fundamental property. The universe only cares about the arrangement of matter and energy. The concept of a continuous self is something our brains construct. It emerges from the stable operation of biological processes inside our bodies. Teleportation threatens that stability by interrupting the physical system that generates our consciousness. Yet the discussion does not end there, because once we start questioning the continuity of identity, an even stranger thought appears. A thought that makes teleportation seem less unique than we might expect. Think about what happens when you fall asleep. When you fall asleep at night, something curious happens inside your brain. The stream of awareness that you call being awake begins to fade away. Your senses shut down, your thoughts dissolve, and the world disappears behind closed eyes. For several hours you are no longer interacting with reality in the same way. The brain enters different electrical states. Deep sleep reduces the activity in regions associated with conscious awareness. From the outside, your body is still there, breathing slowly in the darkness. Your heart keeps beating and your cells continue their chemical work. But the conscious experience that defines your sense of self becomes extremely faint or disappears entirely. Then morning arrives and something remarkable happens. Your alarm rings and the brain gradually wakes up. Electrical activity spreads through the cortex and awareness returns. You open your eyes and instantly assume something important. You assume the person waking up is the same person who went to sleep. The story of your life appears to continue exactly where it left off. But how do you actually know that? How can you prove that the conscious stream that wakes up is identical to the one that faded away hours earlier? Memory tells you it is, but memory itself is just another physical process in the brain. The atoms inside your body have been shifting constantly during the night. Chemical reactions replaced molecules and neurons changed their internal states. Yet when you wake up you feel continuous, as if nothing interrupted the story. This raises a strange philosophical question. If consciousness can pause and restart every night without disturbing our sense of identity, what exactly are we protecting when we fear teleportation? Perhaps continuity is not as simple as we imagine. Some philosophers argue that identity is not tied to a specific set of atoms. The atoms in your body are replaced gradually over time through metabolism. Within several years, most of the molecules that once formed you have been swapped out. Despite this constant replacement, you still consider yourself the same person. Your memories persist and your personality evolves gradually. The pattern remains stable even though the material changes. This leads to a powerful metaphor used by many scientists. Instead of thinking of yourself as a fixed object, imagine yourself as a pattern. More specifically, imagine yourself as a process. Consider a wave moving across the surface of the ocean. The water molecules forming the wave are constantly changing. Individual droplets rise and fall while new ones take their place. Yet the wave itself continues moving forward. The pattern of motion remains stable even though the molecules composing it change every moment. In a sense, the wave is not the water itself, but the behavior of the water. Human beings may function in a similar way. The atoms in your body come and go through food, breathing, and chemical reactions. But the overall structure and activity of the brain maintain the pattern that defines your identity. Your consciousness might be less like a statue and more like a flame. A flame appears stable and continuous. Yet the individual molecules burning within it are constantly being replaced. The identity of the flame exists in the pattern of combustion. If that interpretation is correct, teleportation becomes more complicated. Destroying and rebuilding the pattern might not necessarily eliminate identity if the information remains identical. The reconstructed person would still carry the same structure of memories and neural connections. From the inside, they would experience perfect continuity. They would remember entering the teleportation machine and then stepping out at the destination. To them, it would feel exactly like instantaneous travel. The disturbing part is that the original biological system was destroyed during the process. Even if the pattern survived, the specific physical instance that existed before teleportation no longer exists. The question becomes whether the pattern alone defines the person. Imagine copying a digital file from one computer to another. The information remains identical even though the physical storage medium changes. If you delete the original file but keep the copy, the information continues to exist. Some thinkers argue that humans could be understood the same way. Our identity might be the information encoded in our brains rather than the atoms themselves. In that case, teleportation would simply move the information from one physical substrate to another. However, many people feel uncomfortable with that conclusion. Our intuition tells us that the specific body we inhabit matters. The continuity of physical existence seems deeply tied to our sense of self. This conflict between intuition and physics is fascinating. The laws of nature do not include a special rule protecting personal identity. They only describe how matter and energy behave. Atoms follow equations and interactions. Molecules assemble into complex structures. Eventually, those structures produce systems capable of awareness. From the universe's perspective, consciousness is just another process emerging from physical interactions. It has no privileged status in the equations that govern particles. The universe treats a human brain the same way it treats a hurricane or a star. Both are patterns of matter evolving over time. Both depend on the underlying physical laws. Neither has a fundamental guarantee of permanence. When you consider this perspective, teleportation becomes less shocking. It is simply another way of rearranging matter into a familiar pattern. The ethical and philosophical concerns come from our emotional attachment to continuity. We care about the feeling of being the same person from moment to moment. That continuity creates meaning in our lives. Memories connect our past experiences to our present decisions. Breaking that chain feels like losing something precious. Even if a perfect copy exists somewhere else, the individual who experienced yesterday might never see tomorrow. The copy would inherit the memories, but not the original experience. This is why the teleportation thought experiment continues to fascinate scientists and philosophers. It forces us to confront the fragile nature of identity. It asks whether the self is a physical object, a pattern of information, or something else entirely. Some people might eventually accept teleportation if society proves it works reliably. If millions of people use the machines every day without noticing any difference, public perception might shift. What once seemed like death could become normal transportation. Human psychology adapts surprisingly quickly to new technologies, airplanes. Once terrified passengers who believed humans were not meant to fly. Today, millions of people cross the sky every day without thinking twice. The same transformation could happen with teleportation. After enough successful trips, the fear might fade. The philosophical debate might become less important than the practical convenience. Yet even if society accepts the technology, the underlying question remains: does teleportation preserve the original person or merely create a convincing replacement? Physics alone may never answer that completely. The issue lies at the intersection of science and philosophy. It touches the deepest questions about consciousness and personal identity. Understanding the mechanics of atoms does not automatically explain the nature of experience. What we do know is that the universe operates through patterns. Stars form from clouds of gas following gravitational rules. Galaxies spin according to the distribution of mass and energy. Life itself is a pattern of chemistry capable of sustaining and reproducing itself. Consciousness emerges from the complex electrical activity inside networks of neurons. Each level builds upon the patterns beneath it. In that sense, humans are temporary structures in a vast cosmic process. The atoms inside us were forged in ancient stars billions of years ago. Those atoms assembled into molecules that eventually formed living cells. Through evolution, those cells developed nervous systems and brains capable of thought. The consciousness reading these words is part of that long chain of cosmic events. You are the universe observing itself through a particular pattern of matter. Teleportation challenges the boundaries of that pattern. It asks whether the pattern can be destroyed and recreated without losing the self. The answer depends on how we define what a self truly is. Some scientists believe future technology might bypass the destructive scanning problem. Instead of destroying the original body, teleportation could involve transferring quantum information through entanglement. This concept is already studied in laboratories as quantum teleportation. Quantum teleportation does not move matter directly. Instead, it transfers the state of a particle to another particle located somewhere else. The original state disappears while the distant particle adopts the same configuration. Even this process respects the No-Cloning Theorem. The original quantum state cannot exist in two places at once. It is transferred rather than duplicated. Scaling this process up to a human body would be unimaginably complex. A human contains roughly 10 to the power of 28 atoms. Coordinating the quantum state of such a system exceeds any technology we can currently imagine. But thinking about these possibilities helps scientists explore the limits of physical law. Every impossible idea pushes us to understand the universe more deeply. Even if teleportation never becomes practical, studying it teaches us about the nature of matter and information. In the end, the most valuable part of this discussion is not the technology itself. It is the way it forces us to reflect on our existence. We begin to see ourselves not as fixed objects, but as evolving patterns in a dynamic universe. Your body changes every second through metabolism and cellular repair. Your brain rewires itself constantly as you learn and remember new things. The person you are today is already slightly different from the person you were yesterday. Yet the story continues smoothly enough that you experience it as a single life. The continuity exists because the changes happen gradually. Teleportation threatens to replace gradual change with instantaneous reconstruction. That is why many physicists say they would never step into such a machine. Even if the copy appears identical, they value the uninterrupted flow of experience too much to risk it. The rocket may be slow and uncomfortable, but at least the traveler arrives intact. So if someone someday builds a teleportation booth and invites you inside, you might remember this discussion. You might ask yourself whether convenience is worth the philosophical gamble. Are you willing to trust that the pattern alone defines who you are? Until that day arrives, the question remains safely theoretical. Rockets still carry astronauts across space the old-fashioned way. Planes still cross oceans hour by hour. And perhaps that is not such a bad thing. The slow journey through space reminds us that we are physical beings traveling through a real universe every second of. Experience is part of a continuous story, that continuity may be the most precious thing we possess. It is the thread connecting every moment of your life from childhood to old age. It is the silent engine driving your awareness forward through time. The universe is filled with extraordinary phenomena. Black holes warp space and time. Quantum particles behave in ways that challenge our intuition. Yet among all those wonders, the most mysterious process might be the simple fact that you are experiencing this moment right now. The continuity of that experience is fragile, precious, and deeply personal. Teleportation might promise instant travel across the stars, but until we fully understand consciousness, pressing that button will always feel like stepping into the unknown. And sometimes the safest journey is still the slower one that lets you remain yourself the entire way.